Today we're looking at Glencoe Accelerated Math Lesson 7.3 on adding expressions. So, today we're looking specifically at linear expressions. That means that when graphed, this expression would form a straight line. Okay? That means that we don't have any exponents in it. We have a coefficient, we have an x, and we might add something else to it. Okay? That's a linear expression. Linear expressions are easy to work with because we don't have to deal with any exponents. The majority of what we deal with will be linear. Okay? So, if I had two expressions and I was going to add them together, there's two different ways we can do that. Option number one says we write them vertically. Put our x terms together vertically. We put our constants or number terms together vertically, and then we add them that way. We could do that. But if our lesson last Friday, which was 7.2, was on combining like terms to simplify an expression, could we do the same thing horizontally? We just have more terms. So that's the way that we're going to show it today. Okay? So let's say that I have the example 3x plus 4 . 3x plus 4 is an expression. I put it together in parentheses. I'm going to add to that 2x plus 1. So, I have two expressions, but I need to add them together. Okay? The first thing I'm going to do is use a combination of my associative and commutative properties to rewrite my expression so that my x terms are next to each other and my constants are next to each other. I can't simplify anything that is within the parentheses already, so I don't have to worry about order of operations because as this is written, order of operations doesn't do anything for me. I can't combine anything that's in those parentheses. Okay? 3x plus 2x plus 4 plus 1. So the associative property, let me eliminate my parentheses. My commutative property, let me rewrite my problem so that my x terms are together and my constants are together. 3x plus 2x is 5x. Plus 4 plus 1 is 5. I cannot combine x's and constants. So this is my solution. 5x plus 5. What questions do we have? Sorry. Yes?
I thought you said that if it was like 3x and then on one side and then 2x on the other, I thought you said that you couldn't combine them because it was two different.
No. If it's within the same problem, if the variable is the same, then I can combine them. But if this was a y instead of an x, I can't do anything. If this was the letter t instead of an x, I can't do anything. As long as the variable is the same, I can combine them. Ladies? Does that make sense? Okay. Any other questions? Alright. So let's see what happens if I had something like 3x plus 2 we like having 3 x's plus negative x plus 4. x plus 2 plus negative x plus 4. What would I do first? Yes. Okay, how would I rewrite it?
3x plus negative x plus 2 plus 4.
Okay. What is 3x plus negative x? What?
2x?
2x, yes. Why is it not just 3?
Because it was a negative.
The 3x plus negative x, that means that I have negative 1x. So 3 plus negative 1 is 2, and I have to keep my x.
Is that
Okay.
T or a
Plus.
okay.
If we use the variable t, it would look like this.
Oh yeah.
Okay? That's why we write our variables in lowercase cursive. I've also noticed that some of us are forgetting to do our variables in cursive. We need to correct that, please. 2 plus 4 is?
6.
6. Why did I write it 2? Because it's Monday morning. Alright. There we go. 2x plus 6. Can I combine 2x plus 6? No. That's all there is. There isn't any more. So, the question that was whispered was, so we just keep combining until we can't combine anymore? Yeah. That's what we do. Now, there's one other thing. Let's say that I had a pretty rectangle. And that side length was x. And this was 1.62x. 3. So, how can I find the perimeter?
1 plus 1.62 1.62 plus
How can
times
I?
it. That's wrong.
Okay, let's review first. What is the perimeter?
That outside.
The distance around the outside. So if the perimeter is the distance around the outside, what would I do? Yes, sir.
You multiply both sides and then add them all.
Okay, so you're saying we would have 2 times 1.62x plus 2 times x. Correct? Okay. With a handy dandy calculator.
I have one.
Alright, double check me. 1.62 times 2 is 3.24x. Plus 2x. Is that correct?
Yes, ma'am.
Yes? Okay. What is 3.24x plus 2x?
5.24x.
Good. Is there another way that I could do this? Yeah. How else could I do this? Could I take 1.62x plus x plus 1.62x plus x?
Yeah. Wait, yeah.
Because that gives us 1.62x
Times.
plus 1.62x plus x plus x, which ends up being 5.24x.
Yeah.
Yeah.
Does it matter?
No.
Which one do you think would be easier?
The
First one.
The first one. I would agree with that. But does it matter? No. Questions? Let's say that we had an irregular pentagon. That means we had a 5-sided figure where not all side lengths were the same. Can I use this?
Nope.
No. I'd have to do it this way because all the side lengths would be different. What if I had a triangle? Can I use this?
Yeah.
I can?
No, you have to do 3.
I have to do it this way. So multiplying our side lengths by 2 works if we have a rectangle because that is the definition of a rectangle. Opposite sides are congruent, that means equal length. With other shapes that doesn't happen. So we have to know that this is an option. Okay? Questions? Yes?
If you have an equilateral triangle.
If it was equilateral, we could multiply by 3. Yeah. However, if the lesson is on adding linear expressions, do you think we're going to have that? Probably not. But it would be nice, wouldn't it? Yes, sir. Stretch. Okay. Any other questions? Thank you.